Hello all. Today we are going to see Dijkstra's algorithm, which is a single source shortest path algorithm. This is one of the graphs algorithm. This is used to find the shortest path between one node to all the other nodes in a graph. So for example, if I take a node A, from node A to all the other nodes B, C, D, E, Z, what is the shortest path from this node A? So that will be found out by using this algorithm. So we're going to see how this is solved. So this is a problem solving session. So we'll take this graph as an example and we'll be solving this problem. So we're going to take this node A as a shortest, the source node. So source node is A. The source node being A, the destination nodes. So I'll be putting a small table, destination nodes, and we'll put a total cost for that, and there is a via node. From which node you are coming? The one previous to that, via. So we'll be having the nodes B, C, D, E, Z. Totally 5 nodes which are destination nodes. Source node is A. Source node is A. We are having 5 destination nodes B, C, D, E and Z. So we are going to work for this, how the path is found out. So we have destination nodes B, C, D, E, Z. Total costs to come to that node from A. That's what. So initially it's all infinity. So we'll just put infinity. For all these nodes, it's all infinity. So from A to reach B, C, D, E, Z, it's all infinity. So via node is also, as of now, it is empty. So first initial startup is, you have to put infinity for every node, every destination node from A. From A to every destination node, it's infinity cost. Total cost. This is total cost. So we will start with the scanning from A. We are standing in A. We have to find the shortest path to all the other nodes from A. We are standing in A. So we scan. We scan means we just find out where the A is connected directly. So that's what we scan from A. So whichever is we are discovering, we will be updating the table with. So B from A I can go to B with the cost of 4. So 4 is less than infinity value. Then only I will replace less than infinity. So if it is something less, then we will replace the bigger one. So 4 is less than infinity. So we replace infinity with 4. Then the via node is A. So to reach B, the cost is 4. The previous node is A. The previous node to B is A. Then the B A can go to C also directly with the cost of 2. 2 is also less than infinity. So I'll put 2 instead of infinity. We'll replace infinity with 2. And the via node is A. So destination node is C, via node is A. For these two is filled out. Then comes the next phase where we have to select which one to scan from or which one we have to add to the answer. So out of these nodes, the Dijkstra's algorithm says you have to follow a greedy procedure. Greedy procedure is whichever is smaller, whichever the total cost is smaller, then you have to select that one. So this is the smallest in the discovery. So 4, 2, infinity, infinity infinity. So out of these 5 values, 2 is the smallest. This you have to take it and fix it as an answer, because we are building part by part. So this is a greedy property. So Dijkstra follows greedy property. It's a greedy way of solving. So greedy property is selecting the smallest one. I'll just blindly select the smallest one always, but I'll yield this will yield a optimal answer. That means correct answer. Algorithm correctness will be there just by selecting the smallest every time. So I'll select this one. I'll fix it. This is fix it. The fixer, I'll just put the color as say blue for it being fixed. That means the route to C from A is fixed. C can be reached via A by 2 only. Why do they do that? That's what we'll just do a small thing. Say 4 is here. A to B is 4. A to C is 2. One more thing you have to remember here is Dijkstra's algorithm will work only for positive weights. Positive weights. It will not work for negative weights. That you have to remember. Dijkstra's works only for positive weights. Let us see why that logic is working, the greedy property without positive weights, how that is working. Let us see. So A is going to be with the cost of 4, A is going to C with the cost of 2. There are only 2 outgoing, if I am reached A, there are only 2 outgoing edges. I can go via this edge, or I can take this route. If I take this route, route takes 2 cost. That means I can reach C with the cost of 2. Is there any other way to reach C from A not following this edge but less than 2? Is it possible? So if I go via this way, and if I go to D, then if I come back to C, A to B, then B to D, then D to C, if it is less than 2, then that route should be taken as a path for A to C. But it will not work for negative weights. But if there is a negative weight, for example, this is 4, A to B is 4. If this is minus 5, minus 5 plus 4 is minus 1, and this is minus 8. Minus 1 plus minus 8 is minus 9. So A to C will be minus 9. Here A to C is 2. So this route I will be taking. But since we are not using my negative weights, Dijkstra's algorithm will always use positive weights. So you cannot come taking this route which is already more than 2 and come back to the C with some other path which will always be more than, at least be equal to 4. So if it is if it takes, already it's 4, if it takes some other route, it will maybe more than 4. So you cannot come to A to C by taking a bigger route. So I have to go to the smaller one only. So smaller one will always be correct. So this argument is the base for this Dijkstra's algorithm. Based on this algorithm, so based on this property of selecting smallest, by this logic, this whole algorithm, the correctness will be maintained. So this is selected as the answer. So C is fixed. A to C is over. Now once whatever you have selected recently, whatever that is added to the answer set recently, that will be the next scanning point. So I will scan from C. So scan from C. C goes to A. A is the source, so leave it. Already we are coming from that via only. So C goes to new nodes we have to discover. C goes to B with the cost of 1. So come to C. To come to C is, what is the cost? Because we are doing from A. To come to C, cost is, total cost is 2. C is taking 1. So 2 plus 1 is 3. Because why? We are always starting from A only. To come to C from A is 2. C is going to B with the cost of 1. So 2 plus 1, 3. 3 is less than 4. That means I have to replace. So 3, but via node is C. Because 4 is replaced by 3, and via node is changed. Okay. So this way. Then C can also go to D. D is with the cost of 8. So to come to C is 2. To come to C is 2. Then this is 8. 8 plus 2, 10. Totally 10 from A. That's the meaning. So this is always, the total cost is from A. So 10 is less than infinity. So I am replacing infinity with 10. So via node is C for this. We are scanning from C. Then C can go to E with the cost of 10. E also infinity. So C can go to with the cost of 10 to E. So to come to C is 2. 2 plus 10, 12. 12 is less than infinity. So I am putting 12. Via node is C. So then that's a possibility. B, D, E. We are updated. This replaced. This replaced the infinity. This replaced the 4. This replaced the infinity. So likewise, we have updated the table. Now, the same logic goes here also. So we have to select the smallest one and they have to fix it. That as a root from A. So A to B is total is 3 via C. A to D is 10. One more edge. A to E is 12. So this is the smallest. So I cannot take D root or E root to come to B lesser than 3. So we are fixing it. The same property of whatever I explained earlier, the same property. So A to C, A to B is 3, A to D is 10, A to E is 12. So I cannot come to B from A less than 3 by taking D roots. That means it is fixed. So smallest one, fix it. 3, 10, 12, infinity, smallest one is 3. You fix it. I am making it a blue. That means this root is fixed. A to B is found out now. That's the meaning. So recently added is B now. We will scan from B. If you scan from B, B where it can go? It can go to A, C. A, C are already fixed. This is fixed. A means source fixed. B, C is already done. Okay. So you cannot come via B. That means we are going with a D. So B is connected to D with the cost of 5. So B connected to D with the cost of 5. To come to B is 3. To come to B from A is 3. From B to D is 5. So A to D is 3 plus 5. 3 plus 5 is 8. So, but already we have a 10, which is more than 8. That means we have to replace bigger value with the 8. So 8, which is putting 8 via B. Earlier we have to put via C. So that's it. So B cannot go to anywhere else other than A, C and D. A is a source, C is the already in blue, which is fixed. Then D is replaced. D is replaced via B. Okay. Now next one, out of these 8 and 12 and infinity, which is the smallest. So A to D is 8, A to E is 12. So I cannot go to A to D by taking 12 roots lesser than 8. That means this is fixed. Now D we have to scan from D. D goes to B, B is already added. D goes to C, which is already fixed, blue. Okay, these three are blue fixed. Now D goes to E with the cost of 2. To come to D from A, is 8. Then from D to E is 2. So 8 plus 2, 10. So 10 to E via D. So it is less than 12. So I am replacing 12 with 10 via D. And D goes to Z. This is the first time we are encountering Z destination. D goes to Z with the cost of 6. So to come to D is 8. 8 plus 6 is 14. So 14 is less than infinity. So I am replacing infinity with 14 and via node is D. D can go to E with the cost of 12. This is already done. And Z is done now, newly added. Okay. Now we have left out with two things, 10 and 14. A to E is 10, A to Z is 14. So I cannot go to E from A less than 10 by taking Z root. That means this you have to take it as a blue one. We're taking it to answer set. E is fixed, A to E is fixed with 10. Now recently added is E. So we are scanning from E. So E to Z is 5. To E is 10. A to E is 10. E to Z is 5. So A to Z is 15. But 15 is more than 14. So you should not replace this value. So E goes to Z. There is no need to replace. E to D, already D is fixed. That based on the property. E to C already fixed. So only thing is it can go to Z with the cost of 15. So to come to E is 10, then 5, 15, but 15 is more than 14. So via D is the best route. So that's also fixed. That's done. Now which is the only one left out? This is the only one left out. We are added to the answer set. A to Z is 14 via. So this table is now formed. From this one we are going to find the path. What's the path? First, A to Z. A is the source node. A to B. You just see what's the path for A to B. You can reach B. You can reach B. Destination is B. Destination is B, node B. We'll find the paths. A to B. What's the path for A to B? So reaches B. B can be reached via which node? Total cost is 3. Total cost is 3. Okay. B can be reached via C. So first to go to C via C. So B can be reached via C. Okay. That means then you have to C. Go to this one C. The node C. Node can be reached via A. So that means you have to put like this. So this is the path. A, just put it. Path A to B is A to B path with A to C, then C to B. A to C, then C to B. That's a path. So how to start, I'll tell again. How to do? Just you have to find via B. So destination you put it here. You see the table. In the table, what's the via node for to reach B? The previous node is C. But how will you reach C? Via is A. A is the source node. So you are stopping. You are not going further. A is the source node. Till you reach the source node, you have to follow this approach. Now A to C. A to C, what's the route? Let us see. So C is the destination. C is the destination. C is the destination. A to C. To come to C, it's A. So directly you just put it, no problem. We reach the source node. So that means we fix it. So A to C is just route path is AC. AB path is ACB. ACB. These are vertices. Vertices path. Then A to D. We'll just see how A to D is reached. A to D. D is the destination. You put it here. You see the table. D can be reached via B. So put the via B here. Go to B. B can be reached via C. Put a C here. Go to C. C can be reached via A. But the total cost is this total cost A to B total cost is 3. That is A to C total cost is 2. A to D total cost is 8. Okay, that you can find out easily. You see this one. This is the route for A to D. A to D. D is here. How will you go? A to C. First you go to A to C with the cost of 2. Then C to B with the cost of 1, 3. Then B to D with the cost of 5. So A to B 2 plus 1 plus 5, totally 8. This is A to C. A to C is 2 directly. A to B is AC and CB. AC is 2, CB is 1, 3. Total cost is 3. So this gives the total cost. That's what I put total cost here. A to E. Now you just see for A to E. What is the cost for A to E? You put the E here, destination. E can be reached via D. You put D here. And D can be reached via B. Okay, put the B here. B can be reached via C. Okay, then C can be reached via A. So I will just this is the route. This is the route for. So I'll tell again. So here I'll put the destination. Destination is E. Destination is E. A to E, we have to find out what's the path. You see the table, E can be reached via D. So previous node is D. So how the D is reached? D's previous node is B. You put the B here. What is the previous node of B? B's previous node is C. What is the previous node of C? C's previous node is A. So this is the path. The path is A to E is A to C. AC, then CB edge, AC edge, then CB edge, then BD edge, then DE edge. So 4 edges, 1, 2, 3, 4. You have to cross 4 edges to reach E. So A to C, you have to go like this. Then CB, then BD, then DE. That means 2 plus 1, 3, 3 plus 1, 5, 8, 8 plus 2, 10. Totally 10. 10 is the cost here. Okay, so that's A to E's. Now the same way, A to Z. What is the cost of reaching Z from A, and what's the path? Total cost is 14. That is found out. But what's the path? We have to just see. Reaching is Z. Okay, reaching is Z. How we are reaching Z? Let us see. Destination is Z. Go to Z. Z can be reached via D. D can be reached via B. B can be reached via C. Put C. C can be reached via A. So when you reach A, you have to stop, because that's the source node. Okay, so this is the path. These are all the path. Path is ACB, path is AC, ACBD. Likewise, we are putting the path. So from this table, you have to extract the path. The table gives the total cost from A to B, A to C. The total cost is given, and the via node is given. Via node means just the previous node. You cannot get the full path. So full path derivation, you have to just write a simple logic to get the derivation of full path. A B path is A to C, then CB. It's edge to edge. This AC is directly you can go from this one. So here we are following 1 2 3 edges, A to C, then CB, then BD. So likewise we have. So this is shortest path. You cannot go from A to E in any other path with less than 10. This is the shortest path. That's the meaning. It's what optimized algorithm. So you cannot go to A to Z other than this path, which is having a cost, total cost less than this 14 cost. That is what is optimal. And just by following greedy selection of smallest at every time, we are reaching the optimal. That is why we say it's a greedy algorithm. So this is the problem solving for Dijkstra's algorithm. Thank you.